So today we're really excited to be talking about some new things with search that we're doing that David will show you later. We're going to talk about Stream here in a second. Jim's going to show you a demo, but before he goes into that, just a few things really quick that I wanted to talk about. One, you'll notice that Jim is demoing from Cribl Cloud today, as David will be doing the same. This is our cloud-based offering that offers our multi-product suite. I just wanted to note it is free, not a trial. It's 1 terabyte per day for free. You can sign up for that and use it. So I would love to see the cloud team wonder what in the hell happened today when thousands of people sign up for Cribl Cloud. So please go sign up for Cribl Cloud. You can do that at cribl.io, and you'll have access to everything that you see here. One side note, you might notice a banner at the top that says CriblCon. We will be in Vegas on July 17th for our user conference. So if you're bored and you want to go to Vegas, come see us. We're going to show you some cool stuff there. So real quickly, we're going to start with the OG, as we call it. I like to call it the Greg Brady of our product family, since it's the oldest of our three. And then David will show you Bobby Brady, which is search. We're not going to talk about Edge today. If you want to hear about Edge, it's our super cool managed agent that has a lot of great, amazing features. For the sake of time today, we're not going to talk about it. But if you want to learn more about it, you reach out to us or come to CriblCon, and I'll show you all about it. So real quickly, Nick showed some really cool diagrams, so I don't need to talk about this too much. But on the right, there's a nice little chart diagram there that I always like to use if I'm at a trade show or something before I start a demo to talk about, what exactly, Stream does. Nick already articulated that, but I want to point something out that I think is important to me. I started in this industry like 15 years ago or something. I spent 10 years at Splunk. And back then, people were still grepping their firewall logs and things like that. And when we were able to actually capture and consolidate all that unstructured log information into a platform and allow them to view it and correlate it and do some cool things, with searching and making dashboards, it changed everything, right? And so we solved a major problem, right, which was insight. But with that came a new problem, which is data management. Nick mentioned that. Here at Cribl, I think we pride ourselves on the fact that we really care about solving our customers' problems. That is our key objective. This company was founded on the principle of solving customer problems, especially with data management. So as Jim's going to show you today, like there's a tidal wave of data today, maybe a tsunami, I don't know, pick whatever sounds scarier. And managing that data is getting increasingly hard. We're here to help with that. So I'm going to pass it over to Jim, but just a note, Jim is a security practitioner. Jimmy Old Patents. You've been doing this for like 100 years or something, right? Something like
Thanks.
that. You invented mainframe security or something like that. Jim is a phenomenal resource. We're glad to have him here. I think he's like a Pisces. He likes walking on the beach, pina coladas in the rain, and doing security demos. So Jim, do your thing, and I will stop talking now and let you work your magic.
Right on. So thanks much. We're going to give you kind of a quick high-level tour of what we're doing from a security perspective. Lots of relevant security use cases. As Corey mentioned, I've been around the security space for a long, long time, either coding or networking, anti-fraud, money laundering, SIM design kind of stuff. And I'm extremely passionate about addressing solutions that plague companies in a very duplicitous manner. Many of these companies are fighting with the same exact problems, and to me it just doesn't make sense, right? So that's the mission here, is to really bring forth and address lots of the challenges that all these companies are dealing with, either cloud native solutions or on-prem analytic solutions, and bring those forward into the stream where it makes sense, such that then we can commoditize many of the things that we'll talk about here shortly as we step through some of these use cases. And what I'm going to do is, this is all about data in, data out. This is a streaming device. I had a question come up earlier on a different call. Stream is a streaming device. I'll talk about when we can do batch-like things, which are really important as things are moving towards the cloud. So we'll talk about how we get data or receive data. We'll talk about how we push data from one or more destinations. I'll give you a quick tour in terms of these packs or pipelines, which is essentially what we can do to that data while it's in flight. And again, this is all streaming, right? We don't write anything to disk. So we'll talk about what we do in flight. And then lastly, we'll show you how we connect sources to one or more destinations using these packs or pipelines in between. I think we're looking good on time. So if you do have questions, please jump in. I should be able to answer the questions. Let's take a look at sources. So first things first, in this interface, these tiles are best to be thought of as transports. It's how we just move the data protocols. Lots of them are general, like the rest collectors, which I'll talk about here shortly. A lot of them are really important. Being a network persona from the past, syslog is a big deal. It's been around for a long, long time. And it's time that we show syslog some love and we address the fact that centralization of management, can be a challenge. With syslog, similar story to be told with the Windows Event Forwarder. So it begs the question, why can't we just, well, not even the question. Today we have organizations that are deploying Cribl Stream to take care of the entire syslog infrastructure and manage it through one simple console, enrich it, change it, format it, along the path, deliver to one or more destinations. And again, same thing with Windows. I like this one. Within security, we know that there's an ever-expanding attack surface that we're having to deal with. Cloud is a really important piece to that. And as things become cloud native, as more and more solutions are cloud native, that means that the organizations that have to collect that data now have to be real keen when it comes to personas and writing code to deal with these RESTful APIs. So we're going to see an explosion of these. And this is a good example of where the data isn't necessarily streaming. Wiz is a big partner of ours, so we certainly see a lot of that. So to get at this Wiz data, we're going to use these RESTful configs so we can pull every 15 minutes, maybe we can pull every hour, and then we're going to send them along their happy way to whatever destinations you want to send that to. So again, maybe you're going to build a live CMDB type thing and you need config or audit data. So we can use these APIs on a timed basis to get that data and then deliver it to a SIM tool. Or maybe more importantly, we can deliver it to your destination for long-term storage. And I'll show you how that connects here in just a bit. But again, there's a lot to this stuff. Discover, collect, authentication, pagination, right? We can make this fairly simple with a Cribl interface. And then it's just a matter of running these on an ongoing basis. I'm just going to do a preview, but I could just do a full run here on demand, send this to the routing engine, and then you'll see shortly how that routing engine delivers to one or more destinations. But it's just a matter of click and run. We're going to grab a bearer token. I'm going to get the data, paginate the data, break the data out, and it's just that easy, right? So this saves customers a ton of time. And I think that we're going to see more and more of this cloud-native API RESTful-driven tech activity over time. I hope that makes sense. If you've got questions, jump on in there. Destination-wise, lots of options. And again, we're going to route to one or more destinations here. So analytic platforms, object storage is a big destination platform for us. Today, I'll show you how we're going to write to one of each of those. I'm going to write to log scale. At the same time, I'm going to send full fidelity data that's not been optimized or trimmed down or enriched. From a compliancy perspective, we're going to drop that in long-term storage. So I'm going to show you what the routing looks on that one. But first, we have a dispensary online, and we or our customers or partners can create these packs. And these packs are built to save customers time when it comes time to optimize the data, format the data, drop events, sample PII, masking, all that kind of stuff. I've loaded up a few of those packs here. And we've got some network folks on the call today, so we included Cisco and Corelight NDR. One of my favorites, because I wrote the pack, the Sentinel-1 Cloud Funnel pack. Again, from an EDR perspective, as customers are getting better about building out this concept of risk and quantifying their efforts within the SOC, adhering to whatever CSF they chose, MITRE ATT&CK is probably one of the more popular ones these days, allows them to be quantitative in terms of how they're closing visibility gaps. And you close visibility gaps by onboarding additional data sources. And I think it's over 60% of MITRE ATT&CK these days requires EDR, or some sort of deep visibility endpoint type data. And that's exactly what we get from Windows Threat Defender, from CrowdStrike, from Sentinel-1. And what I'm doing here is version 1, version 2, as we receive that data, I'm going to run them through different pipelines depending on what type of event category there is. My personal favorite, I've been building this use case, I don't know, maybe hundreds of times for customers over the previous 5 years, deals with DNS. So again, DNS, extremely important data source. We can pull these DNS queries right from the endpoints. And because this is EDR data, I'm on the inside. This is what it looks like when we receive it. That's a lot of data for all the right reasons. And I get why that's there, right? There are EDR companies that are doing ML with this data. It's an awful lot of data that customers just don't need in terms of security relevancy, in terms of ingest cost, in terms of performance and retention, right? That story gets pretty compelling when I can do things like look at the outside, and you'll notice that what I've done over here on the drop is I've essentially said, first things first, let's grab a few interesting fields that I intend on keeping long-term in my analytic platform. Things that are interesting. DNS query or request is the big one. I'm going to parse that out. I'm going to take a look at the layer 2 and layer 3 domains. So I want to look at, is that Microsoft.com or Cisco.com? I'm going to look at the layer 3 portion of that as well. I'm going to extract that. And is it upload.microsoft.com or update.microsoft.com? And then within security, we're typically interested in the anomalous events. So from a DNS perspective, I'm interested in the not so frequently seen domain names, or DNS requests, machine generated requests, newly seen domains, never seen domains. So I've got this lookup loaded that has the top 1 million domain names out there, and you can update this as often as you like. The top 100 probably aren't going to change, but I'm essentially saying after that lookup is complete, if that domain is within the top 100, just drop the event. And that's what we're seeing over here. All of these grayed out events are events that we're going to drop. And I'm looking forward here in a bit, but I'm going to drop these events as I send them into my analytic platform. I'm not going to use this pipeline when I write them out to long-term storage. I could, but we're dropping events. And then if we open these events up, you'll see that green means that we've added that field. So I've added some asset or potentially even identity context to the event that may not have been there before. The red fields are ones that we deemed to be not important. So there are a lot of events in here. And again, you can change this at any point in time that we're not looking at to quantify that effort. I'm dropping 90% of the events with a simple DNS hack that says drop the top 100. And this is getting played out in enterprises. Normally, it's not quite that high. Normally, it's between 70 and 80%. But on top of that 90% of the 9.5% that's left over, I'm still shrinking that remaining 9.5% by almost 100%, right? 99%. So it's just a trickle of the original data gets sent to the ingest platform. And again, when we talk about savings across the board, they can be absolutely hard to swallow, right? It's the most important data source, and we can slim this stuff down on a per pipeline basis. That's what we're doing with.
I have a question for you here, Jim. It's Bruno Wallman. Do you still save the original log data somewhere? Because a lot of times it's hard for an organization to drop data. They want to keep it just in case, because they don't know what the future use cases are. So they don't want to completely drop it and get rid of it. So do you still save a single copy of all this information before, and then parse it and send it a lesser version on to the final tool? Yes.
So again, from a freedom of choice perspective, you can do whatever you want. And I'm going to round this out. Let me do it right now because I think that's not next up anyways. So this is all about routing. So absolutely, it's your option to do what you want. And in this case, I'm going to send copies of that EDR data through that pipeline that I just showed you. And then when it returns from that pipeline minimized, I'm going to send copies of that to my output destination. So in this case, an analytic platform. And then I'm going to say, I'm not done with that packet, right? So I'm not writing it to disk quite yet. I'm just saying I'm not done with it. So as we go down the line there, I've got this whole other section that says, no, wait a minute. There are things that I want to send off for long-term retention, or from a security persona perspective, long-term investigations. So I'm going to also say, no, wait a minute. If it came in and it is Cloud Funnel, in this case, I don't want to do anything with it. Right? I want to keep it full fidelity. I don't want to drop packets. I don't want to do any optimizations. Send a copy of those packets into my S3 data lake or whatever destination of your choosing. And then I'm going to mark it as final. So that's the end of it. So I'm actually sending it to both. Many of our use cases are SIM augmentations. Same story played out up here. Instead of sending a copy of that for long-term retention, I can say send a second copy of that through maybe a different pipeline and then send it to a UBA solution. Or maybe it's a SIM vendor that is moving from on-prem to cloud is a great use case, or from one SIM vendor to the next. So once we're in front, and it's really easy to snap stream in front of any platform today. We'll just send it through unmodified, so it really is transparent for the end user. Once we're there, then it just makes it really easy then to either migrate or augment or replace existing solutions. So routing is really
that makes sense. You're not the long-term storage in those. You're just brokering it to what would be the long-term storage in addition to a tool that needs less amount of that data. Okay, thank you.
Yes. So one more thing on this, and this is kind of an important one. So again, your question was spot on in terms of timing. That wasn't a plant, but what we can do is since we know that we wrote that data to that destination, and let me show you real quick in my destination, we're intelligent, and this is the name of the game when it comes to high performance cloud computing, like cloud native storage and search these days. Many of the companies are doing the same thing, and you're essentially creating these partition expressions. So when we write that to S3, we can look inside the packet, we can extract fields, and then we'll create a directory structure. So when it gets written to that object store, I can, in this case, I'm doing it by year, month, day. I can also do it with a directory for source type and source and host. So what you end up using is that directory structure as fields that you can search on just to accelerate the field. So this partitioning expression is really important. So let's say that today you're keeping 2 years worth of data in your analytic platform, and that's insanely expensive from a storage perspective. Now we can write copies off box. We can break that down to 90 days, keep from 90 days in that analytic platform. Many of these platforms make it really hard to thaw that data, pull that back out of storage. Since we wrote it, we know how to replay that, right? So we've got a function called replay. So the analyst can zip right into the same Cribl stream interface. They can replay that data from S3, 4 years ago for, this, the indicator that you're looking for, this thread object or IOC, and then replay that back, into that analytics store within the span of a couple minutes, and that's it. Right. So pushing it out off box like that serves multiple time savers when it comes to the security workflow. Does that make sense? Hopefully good to go.
Yeah, if I can jump on that too. This is Steve. So if I understood your architecture there at the beginning, you are saving or potentially could save the original, I guess, locally in S3 you're talking about as your own data lake of the raw data. And I totally connected with your DNS analogy there because I can remember 10 years ago doing exactly the same thing to cut my Splunk bill at the company I was working for at the time because the DNS query sizes on everything were just through the roof, and you're paying by the byte basically with them. So I see where you're going there, and that's pretty cool, and it's also cool that you can store the original somewhere for the preservation too, because that was always the conversation in the back room with the vice president and the director, like, oh, what if we need that data, that we don't want to pay this gargantuan bill for? This is a nice way. So you end up being the target, instead of syslog going directly, it goes through you essentially, and all these traps, SNMP polling, all that just starts going to this tool.
Yeah, that's right. So instead of managing all those syslog NG devices that are out there, you can take that Palo Alto device or that Zscaler device, whatever it is, point them directly at us. We're a listener, just like the syslog NG devices are, right? So we're just going to receive those devices, and then we'll do some processing. Time zone is a big thing, right? So we've got packs that will allow you to take that inbound syslog format. We can auto-correct for timestamps, reshape that data, do whatever you want with data. And then we can forward it on in there while fixing that big timestamp issue. And again, along the way, We can optimize it. We can drop. We can deduplicate. We can compress it, outbound. And kind of related to your point, keep in mind these stream devices are the workers, right? We've got the control plane, which is the leader, and then the ones that do the work are the worker nodes. You manage those in terms of groups. So ideally, you want a load balancer with a few workers that do the heavy lifting placed as close to the data source as you can, right, to help minimize egress costs. Right. So again, if it's syslog, we're gonna have our worker groups there aggregating data, compressing it way down, and then likely forwarding it on to another Cribl stream instance, which will then relay it, into a destination platform, or they can all write the destination platforms if you like.
Yeah. And you have the flexibility here too. With the other problem we had is like every platform had its own management platform that wants to get that syslog, plus you want it in the central syslog at the same time, and you'll handle sending it one place and making sure that the Palo Alto stuff goes to their management platform in addition to Splunk, and the servers likewise go to their home party tool that the managers insist they have, etc.
Yeah, and related to that, we do have companies like, at least for now, great example, like Zscaler will let you define one destination. But to your point, right, if you need to send it to multiple destinations, you need something that's going to split that data for you, right? So it's a great use case. Yep, good question.
If I can add on to that, and just to confirm my thinking, I'm thinking about your system the same way as, say, a packet broker works in a packet capture system. It does intelligent things to packets or drops certain packets before sending on to the tools at the end of the line.
Yep, that's correct. Packet by packet. And in rare cases, if we do need to maintain some sort of state, or if we're building up like a live CMDB, and again, that EDR data is a great data source, especially whether it's CrowdStrike or SentinelOne, or even Windows Alert Defender, they have a lot of asset identity context in these, in each of these packets. We can very quickly extract what we need out of that. We can push that into a Redis DB. So now we can maintain state across worker groups if need be, or forward those on to whatever you've got on your end that is maintaining some sort of live CMDB. And so again, as we onboard like these really rich data sources, why not extract all of that asset info and update that stuff in near real time by sending it to the appropriate data store on your end as well? Yep, good stuff. I've got one more thing to show you that kind of tails in on that last question there. We hear an awful lot of talk about Amazon Security Lake and OCSF. I've got a quick example that shows from a transform perspective, there's quite a bit that you can do. I think on the IP side of the house over here, if you happen to be interested in formatting your data into whatever vendor schema you're targeting out there, in this case, within many of our packs, if you want to convert that data to OCSF format, let me load the IP side of the house. We're doing quite a bit of stuff in this additional pipeline, but when I look at the outside, it's kind of as we would have expected originally. I can click the button, click save. Then that other pipeline, it's going to quickly reformat all of this data to be OCSF compliant. And we're also going to zip it up into a Parquet file and then drop that off for Amazon Security Lake. So herein lies some of the big advantages of us building these packs out. So it's a very different destination. So yep, packet broker, yep. Same time, we can do quite a bit in terms of masking, encoding data, even encrypting data, ensuring private keys with destination platforms so that the ones with proper authorization can then decrypt some of those fields that have been zipped up. But that was it. I wanted to kind of surprise you with the OCSF stuff towards the end because it's a big bet for us and we're a big partner with Amazon rolling this out. Any other questions, comments? I covered a lot pretty quick.
We're trying to sort out something about your product here in relation to, are you guys just a data broker or are you also a data repository where we can do all the searching and so on natively on the Cribl platform somewhere. Like Stream doesn't look like it does that, but then you guys at the top of this said you were excited about search. So
Yeah, so I think David Caputo is going to talk to that, but you're absolutely right. Stream is just the broker, right? We're just putting packets to where they need to go, right? It's connecting any source to any destination in whatever format that you need, streaming data. Now, Edge, similar story. That's an agent that sits at the endpoint. It does two things mostly. It can be that endpoint agent that grabs data, executes commands, watches, Windows event logs or Linux or whatever, and forwards that data to the destination of choice. But that Edge agent is also sitting there waiting for requests. So part of the bigger picture story that David will talk about, I don't want to steal his thunder on that, is, and Nick said, we're turning search upside down. We are not a repo. We don't store data. We're not in the business of zipping data up so it's like super awesome and super fast and performant for our needs. But you can search data at the edge without ever having to ingest that data. So I think Dave's going to talk about that. But yeah, good timing on that question, again, because it leads right into what Dave's going to talk about.
So you wouldn't be competing against Splunk as far as we've seen yet. You're sending data to it. You're reducing my Splunk spend because we can reduce the amount of data I'm sending into that platform. But you're not competing against Splunk as such.
No, that's where I spent 9 years. I was one of these security strategists for Splunk, great company, awesome products. I was focused on enterprise security. And again, what we're really doing is we're potentially optimizing that data ingest process. So you've got more room, customers have more room to ingest more data. And again, EDR is so important. It's been a big bet for the company over the last 3 to 5 years. But knock that ingest way down, make more room. And ultimately, because potentially the event sizes are so much smaller, that means that each of your searches are that much more performant. If you went down the workload pricing perspective, you've now dropped your search concurrency as well. So it's a pretty complex story that gets played out. But like I said, big fan of that particular destination platform. We get a lot of experience with it.
Lars here. I'm wondering, can you do any filters on the agent, the edge as well?
Yes, absolutely.
Yeah.
So it's best to think of it as it's essentially the stream binary, but it's knocked down and we limit it to one CPU. So absolutely, you could do a bunch of optimizations. What we don't, I think, want you to do, and it's because this is what Stream does, but what you don't want to do is have some kind of server out there that's aggregating a whole bunch of data, and you've got 1 million events per second on that server, and you want Edge to watch those files and then reload those files. That kind of defeats the purpose. In that case, you'd rather just use Stream right there to grab that data, high performance, and then send that out. But yes, you can actually do that kind of stuff inside of Edge.
I'm a little surprised that you, in response to Ethan's question, you would say that we reduce data and not also take the gimme, we help you see the trees in the forest, or the forest for the trees, whichever way you want to look at it, right? Isn't part of the reduction of data to make, if you throw away top 100 DNS entries, doesn't that bring up cream, like someone going to a website you wish someone resolving a website you wish they wouldn't? So you know what I mean? Is the value exactly and exclusively reduction of cost of storage, and there's no benefit beyond that? You know what I'm trying to say? I mean,
So
you're ready to lose
noise,
it. There has to be value in losing it.
Yeah, well, I think it's maybe signal noise is kind of what you're after that. And I think the best example is if you were to try to ingest EDR data, most companies, it's a tough decision. It's a yes or no. Can we afford it? Just hardcore yes or no. So we take that off the table, right? So in terms of signal to noise and optimizing triage, detection engineering, investigations, threat hunting, threat intel, and even adversary simulation, optimizing all of those work streams by just onboarding EDR data, absolutely. Signal to noise,
There you go.
Most valuable data source out there.
It seems like the layup claim to me, not just that we save you money.
Yeah. It's just so much bigger than that. But I mean, that's how many people might see that right out of the gate. But again, I'm a purist. I've spent 5 years operationalizing MITRE ATT&CK, and that's where most of my patents are. So I'm a big fan of, again, taking this very important data source, make it consumable, figuring out how to write detections against this data source that just transforms every aspect of the SOC and moves them out of that kind of reactive mode into something that's more proactive. And that's kind of what Nick was getting at originally is we've got this tidal wave of data headed our way, and we have to be realists about it. We can look at this tidal wave of data and we have to ask ourselves, are we going to be reactive or proactive when it comes to best situating ourselves with that data? And ultimately, it's our job to assist the SOC to best tease the story from that data. And reducing that data is a big topic, right? So I think our timing in terms of entry into the space is an important one. And I think fast time to value, ease of deployment. I mean, everything about the solution is common sense. We just happen to get there first.
Is there a counter argument that says that in order to be accurate, I have to see all the data, and that the goal is to make a data lake that's as big as possible, as cheap as possible, so that my machine learning is as accurate as possible, and that by doing this, you are potentially fragmenting the data and reducing the data, so I have less visibility and less parameters I can train on? Is that a possibility? And if Splunk were 1/10 the cost, and we could absorb everything in and run it over my giant data lake, which is now 10 times cheaper, that I wouldn't need Cribl. Is there an argument there?
That's a tough one, right? Because that's a moving target. I spend a lot of time anti-money
You on
laundering.
that side, yeah.
I always want to say like money laundering, but anti-money laundering and anti-fraud. So from an ML perspective, you're absolutely right. ML is all about feature engineering.
Correct.
And to get to maximize, like you want 1,000 features if you're trying to solve whatever particular fraud problem you're after, you need a lot of context. So oftentimes it's about synthesizing context.
Mm-hmm.
So I think it's more of a, depending on the choices that the customer makes.
Right.
Analytic platforms are generally super fast, but at least to date, they haven't been robust enough to handle massive data sets.
Mm-hmm.
And that's typically where object storage comes into play. Right? That's more of a storage compute kind of thing where they can now use dedicated tools that are built for ML. I think to your point, I think the better place, at least today, in terms of where it gets its data and how it works on that data is probably going to be object storage, just because it's very close to these tools that are capable of actually processing massive amounts of data and all these data frames. So I don't know if there's a solid answer other than we used to only have analytics.
I understand the need for this,
and,
right? I mean, that makes it. I mean, it's convenient, right? Instead of n by n problem, you have an n to 1 and 1 to n problem, right? Which is much more manageable, right? You're reducing that. Network packet brokers, obviously, we use them on a regular basis, and that's part of it for cost reduction. Firewalls are expensive, ID is expensive. You can use them for various purposes. I think it makes a lot of sense. And on the data side, log side, it makes a lot of sense. I think I'm just trying to figure out if, and there is no big data lake in the sky that's cheap and fast. I mean, it doesn't exist. Otherwise, we would just use it, right? I think the only question I have is, if you're trying to use ML, is there a danger that you're reducing some of these features, as you're saying, that they're now missing and you could have trained and detected on, and that
it's a trade-off.
It's a trade-off, right? It's this game where you're now trying to guess at which features could be useful and which features could not, and you're like, let's eliminate these 10 things, I'll drop them. And it turns out that those 10 things, or one of those 10 things, is the actual thing that detects, the new attacks.
But that's the beauty of what Stream does. You can send what you're currently interested in to your analysis tool of choice while sending the full fidelity data to an S3 bucket. Then you realize, oh, I'm looking at the wrong stuff. I need to look at this other stuff. You have that data to go back to.
Yeah, but I think the difficulty I have is that you wouldn't know you're looking at the wrong stuff because it never saw it in the first place, right? So
the people doing the analytics is what you mean, not the
exactly. You've never seen it, right? So the ML model would never ever see that.
Roy, it comes down to what you're filtering, though. I mean, one of the things I'm doing, like if I'm staring at a packet capture, I'm going to filter a whole bunch of stuff as quick as I can and eliminate that 90% and assume that what I'm looking for is in the 10. Sure. And I think they're doing the same thing here. The example they showed us, let's rule out those top 100 domains. There's nothing interesting in there, probably.
Probably
Very high
probably, yeah,
probability.
exactly. I think that's the part.
And this is a classic thing, even in the data warehousing, regular business data
Right, you
analytics.
yeah.
How much do you aggregate? What granularity of the data do you keep?
Correct.
What do you throw away because you think it's bad data when it turns out you needed the bad data to figure out what was wrong where you were collecting it?
This is
It's a
nice.
classic
Yeah.
question.
I mean,
yeah.
yeah.
for sure.
ETL,
Yeah.
do you transform and load everything,
Yeah.
or do you strip some of the stuff because they're not useful?
That's
I mean, it is nice in the sense that you could send it to S3, you could put it in Glacier, right? And you never look at it because it's the cheapest cost, and then 3 years later, you just dump everything because you don't need
Or
it.
it costs you a fortune to retrieve it, because that's
that's
the trapdoor.
that's
The trapdoor.
No, this is
that.
so. I do want to move things along. Certainly valid point, and we see both. One thing I will highlight is with some vendors, like in the AI ops space, they will actually use Stream as a way to condition that data on the way in to give them better data quality, so that their models do work better. So there's a lot of different ways. It's almost like a Swiss Army chainsaw. You can use Stream in a lot of different ways to deal with your data for whatever suits you.
Sure.
So there's a lot of flexibility there.
nice. I mean, I like your Swiss Army scalpel.
Yeah.
Yeah. Either way. Were there any other questions? Or Jim, did you have anything else you were covering?
No, I think ultimately it's about choice, and think of us as the infrastructure, right? So with your ML example, they were probably gathering data from lots of different places, right? So you're still going to have the infrastructure question, even though we may be running to one destination. But that's